I've finally been able to make some meaningful progress on these Inovelli switches. For those of you unfamiliar, Inovelli is an American smart device manufacturer that specializes in premium Z-Wave switches. Unlike smart plugs or bulbs, the switches are hardwired into your existing electrical work, just like a normal switch. It can be a little time consuming if you're doing a lot of them to set these things up, but if you're anything like me right now, you've got a little bit of extra time for some home improvement projects. I did an unboxing and overview of these switches a few months back before we moved into this new space, but today I'll be doing an in-depth review that covers the installation, functionality, and my personal experience with Inovelli smart switches. I've installed about 30 of them so far and have about 20 left to go before the entire house is essentially on smart switches. I've certainly installed enough of them at this point to know what they're about and whether or not they are worth the money. If you're interested in picking some up by the end of this review or any other products that we mention, then please use our affiliate links down below to do so. The first thing to account for if planning to implement switches into your smart home ecosystem is the type of wireless protocol you're going to use. The prevailing technologies are Wi-Fi, Bluetooth LE, Zigbee, and Z-Wave, and they all have their pros and cons, but for my whole home wireless setup, I decided to go with Z-Wave. And if you're interested in me doing a full in-depth review of these different protocols, then let me know down in the comments section. The feature list of these switches is impressive. However, keep in mind that a compatible hub is required to get many of these functions to work properly. I went into great detail in my last video, but basically here are the highlights. Notifications are the main thing that I believe separates Inovelli from the rest of the pack. The on-off switches have a little RGB light in the lower right corner that's used as a visual cue. Using a connected hub, they can tell you if a light was left on or if a window is open past a certain time. The dimmer switches have the same functionality, but they use a full-length light bar, and by default, it's used to show the dim level of the attached light. This light can be customized by color, brightness, or even lighting effect. Your standard switch can perform two functions, up and down. This translates to on and off. These Inovelli switches can perform up to 13 functions that Inovelli calls scenes. These take the form of a double or triple tap, hold, or even interaction with the configuration button. Your hub then sees this and it can be programmed to communicate an action to any other smart device it's connected to. For situations where you have more than one switch connecting to a single device, Inovelli allows you to use an existing dumb switch, another smart switch, or even an auxiliary switch from another competitor. No other manufacturer that I know of offers the same flexibility. You can get this switch up and running without the need of a neutral line. However, if your house does have neutral wiring, I highly recommend using it because there are some features that are limited or unavailable without it. Want to see what devices are driving up your electrical bill or should maybe be left unplugged while you're away? Use the real-time power monitoring feature to get a grasp on where you can be saving energy and money. Disabling the internal relay means the physical switch no longer directly controls what it's wired up to. Have a smart bulb, printer, or webcam hooked up to an outlet that your kids keep switching off? Simply disable the internal relay and now that switch does nothing. If you want, you can then go into your hub and remap that switch to control some other part of your smart home. I'm sure you'd agree this feature list is impressive, but it's difficult to imagine the impact without some real-world examples. Here's just a few ways that we've used these switches in our own home. I can't tell you how many times I've been laying in bed, all comfy, and realize I forgot to turn on the ceiling fan. Now I have to leave the comfort of my bed, walk across the room, and flip the switch like some kind of Neanderthal. Well, no longer. With the whole house wired up to these switches, I can now control everything with a simple voice command, without even being in the same room. Alexa, turn on the den light. Alexa, turn on the den fan. But this goes beyond basic everyday laziness. For those with accessibility needs, they physically may not be able to walk across the room and flip a switch. Being able to use your voice to do this could literally be life-changing for them. While voice control is convenient and a great way to get your feet wet in the smart home industry, it's not truly automation. Now, automation implies the devices are controlling themselves automatically, given external parameters are satisfied. The most common parameter being time of day. Now, my kids have an 8 o'clock bedtime. At 8 o'clock, the playroom lights, ceiling fan, and TV turn off. Their bedroom lights turn off. Their closet lights turn off. Their bedroom ceiling fans turn on, nature sounds begin to play through their Echo devices, and the hallway light dims to 5%. My kids, being too young to tell time, see this as a visual cue that it's time for lights out. I don't know about you, but on more than one occasion, we've tried to leave the house in the morning and forget that the alarm has not been deactivated, of course triggering a false alarm when we go to open the door. So I created a routine that serves as a visual reminder that's only set when the alarm is enabled. When our Ring alarm system is active, the switches closest to the front and back doors turn red and remain that way until the alarm is deactivated. Alexa, arm the house. Even my kids, who are toddlers, understand not to open the doors. I have a similar setup for my kids' rooms, except these switches turn red after their bedtime and return to their default setting in the morning. If they were to open their doors between those hours, I get a notification on the Echo Show on my bedside table where I pull up the webcam of their hallway to see what they're doing out of their room in the middle of the night. Prior to these notifications, I had to deal with toddlers getting out of bed, eating all the junk food in the pantry, before proceeding to jump on the trampoline at 3:30 in the morning. If you have environmental sensors throughout your home, you can use these as additional parameters for controlling your switches. For example, I'm currently reviewing a 4-in-1 sensor, also by Inovelli, that detects motion, brightness, temperature, and humidity. I currently have it placed in the bathroom, and if it senses a humidity level over 75%, it tells the bathroom exhaust fan to kick on for 30 minutes before turning itself off. I'm going to show you the basics of how I wired up my switches, but first I need to provide a couple of disclaimers. I am not an electrician. I'm not providing any electrical advice. I'm only showing you what I did to get my switches up and running. If you are at all uncertain about any part of the installation process, please consult a professional. Secondly, my wiring setup pertains to North American neutral wiring homes built in the last 10 years. Even if your home meets that criteria, your region may have different electrical regulations than mine. If you find yourself at all confused, again, consult a professional. There are several supplies I use to make the process as easy as possible. Flat end Phillips head screwdrivers and a pair of wire strippers are all that's required, but needle nose pliers, extra wire nuts, and spare Romex cable are recommended. I also added a drill, a pair of one-handed wire strippers, and some new screwless faceplates to provide a more modern look. As with any electrical work that I do, the first thing I do is turn off the breaker to the circuit I'm working on. It's also not a bad idea to test the current with the multimeter to double check that the switch is actually off. Removing the wall plate is the next step and needs only a flathead screwdriver. I then pull the receptacles out of the wall to get a good look at the existing wiring. Taking pictures of each one is a good idea. Using the pictures, the old switches can be reinstalled with some level of confidence. If the switch is being installed in a single game configuration, then no further setup is needed. If multiple switches are being installed, the heatsink tabs will need to be removed for the switches to sit next to one another. It's much easier to remove the tabs before wiring them to the wall. Trust me. So I lay the switches down on a table in the orientation that I'll be putting them in the wall. I then remove the tabs. Now, removing the tabs does reduce the ability of the switch to dissipate heat. This decreases the power capacity of each switch. This wouldn't be a problem if the switches control just a standard set of light bulbs. However, higher powered devices such as exhaust fans or ceiling fans may need to be wired to an outside switch so they can retain at least 3 of the 6 tabs. The switch has holes for up to 5 wires, a black line, black load, white neutral, and red traveler, and a copper or green ground wire. The line wire comes from the electrical panel into the switch. If there are multiple switches in a multi-gang box, these lines should be braided together in a pigtail. The load wire connects from the switch to the device it's controlling. Standard on-off switches are likely not going to be using any neutral wires, but they should still be in the back of the box braided into a pigtail. The wire nut is then removed and the switches are connected to the pigtail using the included neutral jumper wires. For 3 or 4 gang configurations, the existing wire nut may not be large enough to accommodate the addition of so many new wires. In this case, simply use a larger wire nut. The included neutral wires may also not be long enough to reach from the pigtail to the switch, in which case a longer one will need to be created from a spare roll of Romex cable. The ground wire can be reconnected exactly how it was before. The traveler wire is only going to be used in 3-way configurations. While I did install 2 of these this way, I won't cover it here since there are so many variables. If you're interested, Inovelli has thorough documentation on their site that likely includes a schematic for your setup. If wiring multiple switches, one switch should be connected and tested at a time. When all the switches are verified to be functioning correctly, some cable management may need to be done, and the switches can then be returned to the wall. A new faceplate can then be installed at this point as well. Physically installing the switch is only part of the process. The second part is getting the switch connected and configured. I use Habitat for my smart home, but the process is largely the same for all the major smart hubs out there. DIY Smart Home Guy has a fantastic video over on his channel that walks through the setup process in great detail for each hub. I recommend checking out his videos when it comes time to actually configure your switch. But just to give you an idea of what you're in for, here's a basic overview. First, you're going to want to go to Inovelli's site and find the code that pertains to your particular hub and switch combination. Keep in mind, some switches need both a parent and child driver to get the notification functions to work. Copy the code and create your new drivers. For Habitat, this is as simple as clicking driver's code and new driver. Once you have your drivers ready, set your hub at inclusion mode and press the configuration button on the switch 3 times. Your hub should automatically detect the switch and assign a driver. It's a good idea to give your switch a name and make sure the driver your hub assigned is actually the one you want to use. When I first install an Inovelli switch, Habitat tries to assign some random driver it already has on board instead of the one I downloaded. This is easily fixed by going into the device settings, scrolling down to the bottom, and selecting the actual driver you want to use. You also want to follow best practices when installing new Z-Wave devices. This includes installing switches closest to your hub first, and then moving out from there. This ensures that you have a robust Z-Wave network. My experience with Inovelli switches was everything I could have hoped it would be, but I still have a few pieces of criticism. While the switches function with incredible reliability, there's a bit of delay between when the switch is physically pressed and when the connected device turns on. This happens even when not connected to the hub, so I don't believe the hub is what's introducing the delay. I think it's something to do with the internal relay. I'd like to see the physical response time shortened up a bit. I really have no other critiques of the device or its functionality. However, I do have some suggestions for ways to improve the installation process. First, the heatsink tabs are just annoying. If you want to put more than one of these switches in a single box, you have to remove those tabs. The best way I found to do it was just with a pair of needle nose pliers and brute force. But even with those, this is not super easy to do. This might be fine if you're just working with a handful, but when you're wiring your entire house with these things, and most of those switches are in multi-gang boxes, your hands really start to hurt. I know these tabs are needed for technical reasons, but if they could find any way to dissipate heat that would allow the switches to sit right next to one another right out of the box, it would make the installation process much easier. They're also significantly bigger than the dumb switches they're likely replacing. I understand they need to fit printed circuit boards, capacitors, a heatsink, and probably a million other things in there, but man, these things are massive. If you're hooking up 3 or 4 of these in a single box, all with neutral wires connected, you're going to have a tough time managing those wires because there is not a lot of space in there. I'm sure they made every effort possible to make these as tiny as they could, but even a little bit of space savings would go a long way. Ultimately, my recommendation will depend on how deep down the smart home rabbit hole you are willing to go. These switches aren't cheap, and that's on top of the price of a compatible hub. Light switches with built-in timers can be found for under $10 at your local home improvement store. Of course, these offer no smart functionality, but if that's all you need is a timer, then that's all you need. Wi-Fi switches are also slightly cheaper as an alternative, but are only effective in small numbers and don't offer nearly the same level of functionality. If, however, your eventual plan is to build an integrated smart home, I'd recommend starting that foundation with something like Z-Wave or Zigbee. And as far as those are concerned, there's nothing else on the market today that I've seen that comes close to offering what Inovelli does with their Z-Wave switches. Well, thanks for tuning in. If you want to use our affiliate links, enter a giveaway, buy a shirt, or ask a question, you can do so right below that like button. If you enjoyed this video, consider watching our other videos and subscribing so you don't miss any more content. Thanks for watching, and we'll catch you in the next one. The wiring setup in my home pertains to North American